Hello, in this video we are going to solve the following challenging problem on the topic of evaluating definite integrals. Consider the following integral. The value of this integral is equal to, pause the video at this point and give it a try yourself to see which one of the following options is the correct answer to the problem. Okay, so now let us solve the problem. Here, what we can do, we can actually, first of all, this is just a constant number, so I can pull it out from the integral, so I can write as 1 plus square root of 3, and then integral from 0 to 1/2, and then I will have 1 over x plus 1 to the power of 2, and then 1 minus x to power 6, totally to power a quarter, and dx. So the trick is to do this. So let me call this integral I. Okay, so I can be written in this form. So from 0 to 1/2, 1 over, instead of writing x plus 1 to power 2, I will write it as x plus 1 to power 8. To compensate for that, I divide by x plus 1 to power 6. Okay, and then I have 1 minus x to power 6 there as well. And of course, I have totally to power 1/4. And then I have dx. Okay, what is the benefit of doing this? First of all, if you don't mind, let me also apply this power within here and there. So this becomes integral from 0 to 1/2, 1 over x plus 1 to power 8 to power 1 over 4 becomes x plus 1 to power 2. Here I can write 1 minus x all over x plus 1 to power 6, but to power 6 then to power 1 over 4 becomes to power 6 over 4, which is 3 over 2. So it becomes 1 minus x. I can write 1 plus x. There is no difference between x plus 1 or 1 plus x. And then I would write it to the power of 3/2, and then I will have dx. Of course, if you are good in differentiation, you realize that x plus 1 to power 2 is an indication that it is a good idea to take this as a new variable. So I will do this. At this stage, I would say that let u be 1 minus x over 1 plus x. Then I calculate du. So this is the quotient rule. The derivative of the numerator, which is minus 1, multiplied by the denominator itself, which becomes minus 1 minus x, minus the derivative of the numerator, which is 1, multiplied by the numerator itself. So it becomes minus 1 plus x, and divided by the denominator squared, and then totally dx. And now the good thing is that this minus x and x are gone, so I will get minus 2 over x plus 1 to power 2 dx. Okay? And that is exactly a good idea, because the only difference here is that I have 1 instead of minus 2. So that's a minor problem. I divide everything by minus 1/2. I divide everything by minus 2. So this becomes minus 1 over 2 du equals to 1 over x plus 1 squared dx. Okay, but now the old variable x goes from 0 to 1/2. This means that my new variable goes from, if I replace x with 0, u becomes 1. And if I replace x with 1/2 here and there, so it becomes 1/2 divided by 3/2, so it becomes 1 over 3. Okay, so now the integral I is equal to the integral from 1 to 1/3. Okay, and instead of 1 over x plus 1 squared dx, I put minus 1/2 du, but minus 1/2 is a constant. I pull it out, and then what is left for me is this u, in the denominator to the power of 3/2, and then I have 1 du. But this is extremely simple integral to calculate, so I bring it up, so it becomes -1/2, integral from 1 to 1/3, and then I will have u to the power of -3/2 du. But then this becomes -1/2. This integral is u to the power of 1 unit more, which is -1/2 divided by -1/2. And then I have to run it from 1 to 1/3. But this -1/2 and that -1/2 are gone. And then I can write it as 1 over a square root of u, because u to power -1/2 can be written in this form. And it goes from 1 to 1/3. So if I put 1/3 here, it becomes a square root of 3. If I put 1 there, it becomes -1. But be careful. This is just I. My question mark is I multiplied by 1 plus a square root of 3. So my question mark becomes a square root of 3 plus 1 multiplied by I, which is the square root of 3 minus 1. But that is the conjugate rule. So the answer becomes the first one squared minus the second one squared. So the answer simply becomes 2. Okay? So the answer to the problem is equal to 2. This is a creative way of solving the problem, but you can also solve the problem in a little bit different way, in a very standard way. So what do I mean by that? Because if you simplify this integral from the beginning, what can you do? You can write integral from 0 to 1/2, and then you have 1 plus a square root of 3, and then here I can write x plus 1 to power 2 to power 1 over 4, which becomes a square root of x plus 1, and the other one becomes 1 minus x to the power of 3 over 2, which I can write 1 minus x is the square root of 1 minus x, and then I have dx. And then what happens, this becomes integral from 0 to 1/2, 1 plus a square root of 3 dx divided by, this becomes a square root of x plus 1 times that. Using the conjugate rule, it becomes 1 minus x squared. Then I will have 1 minus x here as well. But this is very standard. Of course, then you have to use trigonometric substitution, yes? Because of existence of this integral, this is a very classic example of trigonometric substitutions. So what you do, you introduce x to be sine theta, and then you can easily solve this integral using this standard trigonometric substitution. It becomes a little bit lengthier, but it is in principle possible. But if you are more creative and you can see this change of variable, then you can solve it using very elementary methods. Because the method of trigonometric substitution usually is a little bit more advanced techniques in calculating integrals. But it is very standard. So as soon as you see this integral in your integrand, you need to remember about trigonometric substitutions. But if you are creative, you can find the solution very easily without even using trigonometric substitutions. Okay, so if we go back to the problem, so the problem, this is the correct answer to the problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.